Today, we'll continue with right triangle trig. A trig function compares two sides of a right triangle. So, there are 6 different ways to look at the sides. Let's say this is the angle and you have A, B, and C. You could say A over B or B over A over C or C over A, B over C or C over B. There's 6 different ways, and that's why we have 6 different trig functions to explain all the ways to compare two sides of a right triangle. So far, you know sine, cosine, and tangent, and which two sides they compare. But today, I'd like to introduce you to their reciprocal functions. The reciprocal function, remember, reciprocal means when we flip a fraction upside down. Okay, that's the reciprocal. So the reciprocal function for sine is cosecant. As a matter of fact, I'd like to spell that out for you. The reciprocal is cosecant. And we abbreviate that CSC. Okay, we can't use the first 3 letters. That's already taken with cosine. So we cannot do that. And the reciprocal of opposite over hypotenuse is hypotenuse over opposite. The reciprocal function for cosine is secant. Closely related here, as you can see, just like sine and cosine are closely related. And we'll talk about that co-relationship later. The abbreviation for secant is SEC, and that compares the hypotenuse to the adjacent. Notice we've just flipped this one upside down. And there's one more reciprocal function, and it is called cotangent. And we abbreviate that COT. And that, oh no, I have a mistake right there. Let me correct that right away. That should be opposite over adjacent. Okay, so now as we look at the reciprocal function on that, when you flip that upside down, you have adjacent over opposite. So, just to recap, we have 3 new trig functions: cosecant, secant, and cotangent. And those can be explained by simply taking the reciprocal and flipping our original 3 upside down. Now, let's see how to use them. Find the 6 trig functions for theta. So, we already know sine is opposite over hypotenuse. And if you forgot how to do that, you can ask my boo, Sokatoa. Alrighty. And he'll remind you that sine is opposite over hypotenuse. Okay. And so the first thing I want to do is go find my angle and label my sides. Opposite of theta is 4. Touching is the adjacent side and the hypotenuse. Quickly, we notice that we don't know the hypotenuse. So we can use Pythagorean's theorem to find the missing side. I'm just going to call it x for the moment. Leg squared plus leg squared equals the hypotenuse squared. 4 plus 16 is 20, and we'll take the square root. And the square root of 20 can be broken down to 2 radical 5. So the hypotenuse is 2 times the square root of 5. So opposite is 4. Hypotenuse is 2 radical 5. That reduces. But I have to rationalize. So I'm going to do radical 5 over radical 5. And I get 2 radical 5 over 5. Wow, I didn't leave quite enough space for that. 2 radical 5 over 5. For cosine, we're looking at adjacent over hypotenuse. Adjacent is 2. And hypotenuse is 2 radical 5. I like to reduce first. And now I still have to rationalize. So on top, I get the square root of 5, and on the bottom, 5. Now for the tangent, I need opposite over adjacent. And that simply reduces to 2. Now, the next part, you can do a couple ways to do the reciprocal functions. You can flip the final answer, but I prefer to flip the ratio from the very beginning and just look at this as hypotenuse over opposite. So the hypotenuse is 2 radical 5, and the opposite is 4. So my answer is radical 5 over 2. Secant, well, the reciprocal of cosine would be hypotenuse over adjacent. So the hypotenuse is 2 radical 5, and the adjacent is 2, and the square root of 5 is my answer. Now, for cotangent, the reciprocal of tangent, which is opposite over adjacent, is adjacent over opposite. So the adjacent side is 2, and the opposite side is 4. That reduces to 1/2. So we found the missing side, and then we were able to compare the two sides depending on the instructions that were given. Sine, the instructions tell you there, do opposite over hypotenuse. Example 2, what is the cotangent of 30 degrees? Well, you are not given a triangle, and that's because you can draw any 30, 60, 90 triangle that you like. And across from the 30 degrees is your short leg, which is 1. The hypotenuse is 2. And the long leg is radical 3. So the cotangent is the reciprocal of the tangent. So this would be adjacent over opposite. Adjacent to the 30-degree angle is radical 3, and opposite is 1. So my answer is the square root of 3. Let's try another problem similar to that one. Evaluate the secant of 45 degrees. So we want to draw a 45, 45, 90 triangle. Of course, my favorite is 1 on each leg and radical 2 on the hypotenuse. 1, 1, radical 2. Now, I know that secant is the reciprocal of cosine, okay? And it might take you a while to remember which ones are reciprocal functions. Tangent and cotangent are easy to remember. And the way I remember the others is that sine goes with cosecant. Never put the two S's together and never put the two C's together, okay? So I have SC and CS. Never put the same letters together. And that helps me keep it straight. So for secant, I want the reciprocal of cosine. Cosine is adjacent over hypotenuse, so I want the reciprocal. So the secant is hypotenuse over adjacent. That's the square root of 2 over 1. So square root of 2, final answer. Example 4. If cosine theta is 4 over 7, evaluate the cosecant of theta. Wow, let's think about this. There's no triangle here, but I've been given instructions. Let's follow them. I'm going to draw a generic right triangle, and it probably won't be to scale. And I'm going to put theta in one of the corners. And now I'm going to follow directions. Cosine is adjacent over hypotenuse. So I'm going to put 4 on the adjacent side and 7 on the hypotenuse. Now I'm going to use Pythagorean's theorem. Maybe call that x. X squared plus 4 squared equals 7 squared. And so I'm going to subtract 16 from 49. And that gives me 33. And I'm going to take the square root. So x equals the square root of 33. So from this angle, this is my hypotenuse, this is my adjacent, and this is my opposite. Now, that'll make it pretty easy for me to find the cosecant of theta. Cosecant is the reciprocal of sine, which is opposite over hypotenuse. So this one is hypotenuse over opposite. The hypotenuse is 7, and the opposite is the square root of 33. So I just need to rationalize, and my answer is 7 radical 33 over 33. Okay, so just to recap that process, I used Pythagorean's theorem to find my missing side. But first, I had to make up my own triangle by knowing that cosine is adjacent over hypotenuse. So I put the 4 on the adjacent side and the 7 on the hypotenuse. Now, why do we need to learn trig ratios anyway? The main reason is to find missing sides or angles in a right triangle or in a triangle. Eventually, we won't stay in right triangles. Alrighty, example 5. Let's solve for x. So what we want to do here is evaluate what sides we've been given. From this angle, I know the opposite side and I know the hypotenuse. Well, I want to know the opposite side. So now I ask SOHCAHTOA. And remember, you start with so, like so what. Make sure you spell it correctly or it'll mislead you. So I have opposite and hypotenuse, which meet here. So that tells me to use sine. So now, very carefully write your equation. Sine, and always put the angle right next to your trig function. Then put your equal sign, opposite on top, and hypotenuse on the bottom. Now, I just need to solve this equation for x. Keep in mind, this is simply a number. Someone has previously, a long time ago, made a right triangle with a 59-degree angle and figured out what the ratio should be for the opposite over the hypotenuse. And they made tons of tables, and then with those tables, they've programmed those tables into your little calculators. So lucky for you, you can just pick up a calculator. So in order to get x by itself, I'm going to multiply both sides by 13. And I'm going to get that x equals the sine of 59 times 13. Be careful not to multiply the 13 times the 59. Order of operations. We have to lock the sine 59 together. So on my calculator, I'm multiplying those two values, and I've asked you to round to the nearest tenth. So x is approximately 11.1, and I need to include units. If this side is centimeters, the side I just found is also centimeters. And that's approximately 11.1 centimeters. Let's find another missing side. Please pause your video and see if you can figure out if this should be sine, cosine, or tangent. Okay, hopefully you looked at the angle and said, I have adjacent and I want the hypotenuse. A and H, if you look at SOHCAHTOA's name, you'll see adjacent and hypotenuse belong to the cosine function. Now, you could definitely use the reciprocal functions, but you don't want to do that because the reciprocal functions are not on your calculator. So you want to stick to sine, cosine, or tangent. So the cosine of this angle is adjacent over hypotenuse. Whenever the variable that you're looking for is in the denominator, think of the proportion, multiply these two together. I always like my variable in front. And that'll equal 1 times 28. And we want to get x by itself, so we divide both sides by cosine 21. Remember, that's locked together, okay? That is locked together. On my calculator, I'm going to punch in 28 divided by, or you could use the fraction key, That would be great if your calculator has one. And I get, on my display screen, I have 29.99205 and some more numbers, okay? You've been asked for the nearest tenth. So we look at the next number and say, uh-oh, that's over 5, so you round up. And that is 30.0. And if it says the nearest tenth, you have to show that 0 to show that it's very accurate and that it wasn't 29.6 or 29 point, this shows the accuracy. So make sure you do that. So X is approximately 30.0 meters. And you'll learn more about specific digits and more about rounding. Does this answer make sense? 30? Yeah, about 30 meters sounds good. Remember, the hypotenuse has to be the longest side. Now for our final example. This time we're looking for a missing angle. When looking for a missing angle, things change a little bit, okay? But we are going to start off the same way, evaluating which sides are present. We have opposite, we have adjacent. Those belong to the tangent function. The tangent of the angle, we don't know the angle. This is the unknown. Put opposite on top, adjacent on the bottom. Whenever solving for an angle, warning, you're either going to use inverse sine, inverse cosine, or inverse tangent. These are also known as arc sine, arc cosine, arc, you could put the arc in front. These mean the same thing. But for this one, we're going to use arc tangent. And the little -1 means inverse function. That's how we're going to undo it. Okay? So if we take the inverse tangent of both sides, these cancel, and I'm just left with the theta equals to the inverse tangent of 9/16. Just always remember when looking for an angle, these are for missing angles. Okay, make sure you use inverse. When you're looking for a side, you just use the regular sine, cosine, or tangent. I hope that's clear for you. So now in your calculator, you're going to push inverse tangent. Most calculators, you have to hit the shift or the second. And then I'm going to hit the fraction key and do 9/16 and enter that. And I get theta is approximately 29.4. Now, what are my units? We found an angle, so the units are degrees.